Section 2.4. Doing work on the system and changing the system energy from a molecular level perspective. In quantum mechanics, we learned that molecules occupy discrete energy levels. The number of molecules in each energy level is the occupation number of that energy level. If heat flows into the system or work is done to the system, the total energy of the system increases, but in two different ways. Let's look at work first. When a system is compressed, work is done to the system. In this case, all discrete energy levels shift up. However, the occupation numbers of all those energy levels remain unchanged. For example, let's say we have a system consists of 4 molecules. The initial state is this: 4 molecules occupying the lowest energy level, so each molecule has 1 zeptojoule energy. And 1 molecule occupies the second lowest energy level with 2 zeptojoule of energy. So zepto is 10 to the power of negative 21. So atto is 10 to the power of negative 18. And then you have some other prefixes. The final state of the system, after work is done to the system, still has 4 molecules in the lowest energy level and 1 molecule in the second lowest energy level. However, these energy levels shift up. Now the lowest energy level has 2 zeptojoule. The second lowest energy level has 3 zeptojoule. So work is actually the difference between the final energy of the system and the initial energy of the system. So in the final state, you have 4 molecules with 2 zeptojoules. You have 1 molecule with 3 zeptojoules. The initial state, well, the lowest 2 energy levels are 1 and 2 zeptojoules. So you compute the difference, the energy increases by 5 zeptojoules when the system is compressed. Now, what about heat? When heat flows into the system, all energy levels remain unchanged, but some molecules move from lower energy levels to higher energy levels. So let's look at this picture here. So this is low temperature. When we heat it up, the temperature goes up. Some molecules, in this case, 4 molecules move up from the lowest energy level. 3 are in the second lowest energy level, 1 in the third lowest energy level. If we keep heating up, more and more molecules are moving up. They start to occupy some even higher energy levels. However, if you look at the spacing between the energy levels, they are the same. If you look at the energy levels, they remain unchanged. So now one numerical example. Let's say a system consists of 4 molecules in the lowest energy level with 1 zeptojoule, 1 molecule in the second energy level with 2 zeptojoule. So the final state, let's say now we have 1 molecule move up from the lowest to the second lowest energy level. Then we have 3 molecules with 1 zeptojoule, 2 molecules with 2 zeptojoule. What's the result? Well, Q is simply 3 times 1 plus 2 times 2. 3 molecules with 1 zeptojoule, 2 molecules with 2 zeptojoule, minus the initial state. The result is this: the internal energy increases by 1 zeptojoule because of the heat. And again, there's no change to the energy levels. What's changed is the occupation numbers.